Hello everyone. So this video is going to go over the idea of indifference curves very briefly. So if you recall, indifference curves are the way we depict utility functions of the form u of x1 comma x2. So x1 and x2 are the quantity of two goods that the consumer is consuming. And an indifference curve is a curve that includes the set of all points x1 and x2 that give the same level of utility. And a collection of indifference curves is called an indifference map. So each point represents a given level of utility, and the higher up you go in the indifference map, so indifference curves that are above and to the right of a given curve, they're going to have higher levels of utility. And that is what I depicted by this expression here. Now, we saw in class that mathematically, an indifference curve is going to be defined as u of x1, x2 given by u0, which is a particular indifference curve that we are considering. So, and we saw in class how the indifference curve is downward sloped and how the trade-off, how the slope actually captures the trade-off between one good and another. So here, if you are at point A, then you have a lot of x2 but very little x1. So you're willing to give up a lot of x2 to get just 1 unit of x1, and that accounts for the steep slope there at point A. And when you're, say, at point B, then what happens here is that you have a lot of x1 with very little x2. So you're willing to give up just a little x2 to get an extra unit of x1. So and that's why the slope here is a little bit flatter, whereas here, it's going to be pretty steeply sloped there. So, and the downward sloping indifference curve actually symbolizes this trade-off relationship. And the slope at any point of the indifference curve is given by dx2 by dx1. And we saw that the negative of the slope is called the marginal rate of commodity substitution, indicated by minus of the slope, which is minus dx2 by dx1. So, and we saw in class how to arrive or how to compute this dx2 by dx1 by very neatly using the fact that the utility function is depicted in this way, where u0 is a constant. And so, if we plug in the small indifference formula here, then we are very conveniently able to capture dx2 by dx1. And the negative of and dx2 by dx1 actually happens to be just the ratio of marginal utilities, of course with a negative sign. And when you take the negative of dx2 by dx1, which is what is given by MRS, you end up getting that MRS, or the marginal rate of substitution, is actually just the ratio of marginal utilities of the two groups. So we saw this in class the other day, and now I just want to go over an example where we actually compute an expression for MRS in terms of x1 and x2 when we are given a utility function of this form. And we want to compute the MRS at a particular point. Remember, the slope of the indifference curve is going to change at every point because it is a non-linear curve. And when the slope is different at every point, MRS is also going to be different at every point. And this makes sense, right? Where you are on the indifference curve determines how much you're willing to give up one good for another, which is exactly what the marginal rate of substitution is all about. So let's go ahead and compute this. And we know MRS is actually just dou u by dou x1 by dou u by dou x2. Now, if u is given by x1 to the power half and x2 to the power half, we can say that dou u by dou x1 is actually just going to be, I'm going to differentiate with respect to x1, keeping x2 constant. So this will be half x1 power minus half and x2 power half. And similarly, dou u by dou x2 is just going to be half. X1 is just going to be a constant. X2 will now have minus half. Therefore, MRS is just the ratio of these two. And we get that by half x1 power minus half, x2 power plus half, by half x1 power half, and x2 power minus half. So the half and half will get cancelled. So I'm going to have an x2 power half plus half in the numerator. I'm going to have an x1 power half plus another half in the denominator. So essentially, x2 by x1. So that is it. So that MRS in this particular case is given by x2 by x1. And we're asked to find MRS at the point 300, 500. So when x1, x2 is 300, 500, therefore MRS is just going to be 500 over 300, just 5. And what's the interpretation of this? If x1 increases by 1 unit, you're willing to give up 5 by 3 units of x2 to maintain the same level of utility. So if x1 goes up by 1 unit, x2 decreases by 5 by 3. If x1 comes down by 1 unit, x2 increases by 5 by 3 units. So that is what this MRS means. What's the second part of the question? What is the increase in x2 required to maintain the current level of utility when x1 falls by 3 units? Great, great. So I told you that if x1 falls by 1 unit, x2 increases by 5 by 3 units to maintain same level of utility. So if x2 is now going to, if x1 is falling by 3 units, then x2 increases by 3 times 5 by 3, will increase by 5 units to maintain utility. Same utility. And you can actually check this by, so you have u of x1, x2 is x1 power half into x2 power half. Now you have to compute u of 300, 500. So you can just do 300 power half into 500 power half and compute the answer. And now we're told that x1 decreases by 3 units, so it's now at 297. And to give the same level of utility, x2 is going up by 5 units, so this will be 505. So compute this and check for yourselves. So you have 297 power half into 505 power half. And you should get both of these to be roughly the same. So then you know you have computed the right answer. So I just wanted to briefly do just an example showing how to calculate MRS and what it means and how you can play around with that number and figure out other questions of interest. So I will stop this video here and I'll see you in another.